I'm going to focus in this presentation on one specific particular area of platform engineering, and it's paging in the cloud. First, a little bit about myself. I'm Tjebbe. I've been working at Bol.com now for 2 years, more or less, and before this I worked at KPN, as the operations part of KPN. And I like music, mostly older music, guitar music. I like traveling, I like art, I like hiking, and I've been to this area myself. It's the Hardangervidda in Norway, also in that weather, so it was really cool. Music, I live in Amsterdam. I'm from The Hague, so I studied artificial intelligence and system network engineering as a master, so that's a little bit about me. But it's not about me, it's about paging. And there's oftentimes multiple concepts in paging. There's monitoring, alerting, there's end-to-end paging, and notifications and stuff like that. And all those terms are mangled a bit around. I mean, they're used interchangeably. Also, metrics is there to make it a little bit clear. The thing I'm not focusing on is to gather the data from the systems. That's like monitoring more. Alerting is defining when something is going wrong. That's also something I'm not focusing about. I'm focusing on the last part of the journey of such an event, and that's getting the information to the right person at the time. That is the person that needs to take action to do something about it. This is where we came from. Bol.com, we still have lots of stuff in the data center, and we're moving to the clouds nowadays. And those two areas are very differently, and you all know that, I'm sure of that. In the data center, we used to have one big Nagios instance checking all the things, and then coupled to that, we have still SMS modems, so that if something goes wrong, then a text message being sent out. Those are tied together with scripting and also with some custom-made front ends, which you can use to change the phone number of the engineer on duty. That's what we came from. Well, we're going to the cloud, and we want to go there fastly. And so we also need to have something in there. And we thought, are we going to build Nagios in the cloud? And we thought, no, let's not do that. No, it might not be such a good idea. So what did we do? What do we do? First of all, we think that all paging and monitoring comes from information. And information in the cloud is mostly metrics, also logging, but metrics is more interesting for monitoring and for alerting. So we base it around metrics. We use Prometheus for that. I don't know, there are lots of people of you using Prometheus in the cloud? Yeah, so you know it. That's good, great. I like it. It's fun. Metrics-based monitoring in the cloud. Did I want to say anything about it? No. Let's see. I wanted to maybe draw something on the board. I asked, could I draw something? But then we weren't sure, so I created like this thing anyway. This wonderful drawing. This on the top left is supposed to be a cloud. It's like a sort of rectangular cloud thing. It's the applications. Then there's Prometheus scraping metrics from applications. In Prometheus, there are rules defined when something goes wrong, and if something goes wrong, it fires, and it fires to Alert Manager. Alert Manager also belongs to the Prometheus class, but then there's the gap, because on the top right is our friend, the standby engineer on duty, as we call it, and he needs to be informed at 3 o'clock in the morning. But how does he get informed? Well, that's the question that we're heading to. We were looking at different solutions, and this is something that's kind of funny, because we just learned that if we can, we always need to choose a managed solution. As a matter of fact, we didn't really. Well, let's not have that yet. I mean, these were containers which we all thought about. Some longer than others. Are these familiar logos? No. Do you use any of these?
I've used upstream and PagerDuty.
Upstream and PagerDuty. PagerDuty was also widely used in the past more, I think. Also VictorOps users?
Yeah.
Are your experiences so far with it? They're good?
I only started a few months.
Yeah. I think they are all need solutions, and we investigated them. But eventually, most of them, were not fit for our purpose. And most of the time, sometimes it was because of technical fitness. Sometimes things we wanted to do with them we couldn't do, like multi-tenant things and all. But most of the time it was actually finance. It was that they are just too expensive for us, and that's the part that I think I might want to divert from the always to go for managed solution, because sometimes, and Bol.com is quite big in terms of employees, sometimes managed solutions are just too expensive by number of employees, and that was the case with almost all of these. So eventually we ended with the top right one, which is Iris Oncall. Do people know Iris Oncall from you already? No, that's great. So I can maybe learn something, or I get you familiar to it. We settled on these, so like I said. And why did we do so? Well, Iris Oncall has been launched. It is developed by LinkedIn, developers of LinkedIn. It was launched and showed by a blog post of them, a fancy blog post, like okay, we open source this and it works fantastically, and use it. And then we thought, okay, let's investigate it. And eventually, it wasn't as smooth as they promised, but still, it was open source. We could host it ourselves. We could tailor it to our needs, so that was important stuff for us. And most of all, it was financial scalable. So we needed to put quite some effort in it to get it running. Once we got it running, our prediction was that it would run quite nicely with, well, some maintenance, but not too much, and then we could scale up in terms of our developers without it getting too expensive. Well, what is Iris Oncall? Iris Oncall are two components in a platform belonging together. There's Iris. Iris is, well, it's not over here yet. I don't want you to read these. But Iris is its focus is the incident and getting the incident to the receiver. And Oncall is the calendar application. So in Oncall there's a team page, and you can fill in your details. So Iris is about the alert, all about the alert, and Oncall is all about the user and the team. And that translates to these components. Iris has a GUI. There's escalation plans in it. There's incident overview in it. Messages, you can find messages that have been sent or tried to send. And they're both implemented in a sort of a, services way, microservice you could call it maybe, I don't know whether it's truly that, but there's an API server, a GUI server. There's a sender which sends a message to a recipient, and there's a syncing process which makes sure that the data in the application is right and correct. Then Oncall, more or less the same. Also a GUI with user contact details. There you can fill in phone numbers, email addresses, and stuff like that. Then there's a team page with a team calendar in which you can see who's on call at that very moment, and also in the future and in the past. Schedules, when do you want people to be scheduled, and a roster, which is the name for like a rotation, a group of people doing the standby together. And also services like an API server, the scheduler which fills in the calendar, and a syncing script, which in our case syncs user details from our LDAP. I do have another nice drawing. This time I didn't make it myself. On the left you see the metrics platform, Prometheus, which fires to Alert Manager. Then it posts an incident to Iris. So Iris is a receiver from Alert Manager. Iris, once it gets an alert from Alert Manager, and the alert has a label which has the name of the Iris escalation plan. It then looks up, it knows to which team it belongs by means of the label, and then it queries Oncall to see which user at that time is the current standby user. Well, then it gets that information back, and then it creates a message and puts it into the database, the Iris and Oncall database, underneath it all. And then another process of the Iris ecosystem is the Iris sender. It gets that message, it queries the database every minute. And then in the sender, vendors are configured which can actually send the message. And vendors are, in our case, this is actually an old fix because HipChat is no longer under us. We don't have it anymore as such. But one of them is MessageBird, which used to be Twilio, I think, or something. Yeah, it's the SMS and voice call provider, and just plain email. But we also have chat now, Google Chat. And the sync script sync from the Alba, and yeah. So this is the overview of all the components. Let's see. Well, our implementation, and that's where we do use managed services. Luckily, otherwise I would have. Well, so we run it on Kubernetes. We implemented it with containers, and we use the Cloud SQL, Google Cloud SQL database underneath it all. And the sync scripts are implemented in Python. So and they run every interval. In our case, normally once every hour. So, but that could be more or less according to your needs. Well, I think, yeah, this is the thing. What do you do if the monitoring fails? Because if it fails, you don't get messages, and hopefully we don't get messages too often. So it might have failed already, right? So what if it fails? Well, we implemented another thing for that, and that's called a deadman switch. And we implemented it by means of deadman snitch. Do you know that process? Have any of you implemented such a thing?
Deadman switch.
No? Well, I'm going to show you the concept.
I know it from trains.
While I'm going to show you the components, like because it's a good use case of how the life of an alert. So I think this is the time for the sort of demo. It is demo in a way that I was actually planning to do something like building it at the moment, but then again I didn't really got it in time. So I'm just going to show you the running thing. Real stuff.
You know what?
And
You know what?
let's see.
Oh yeah.
This, and then you can't really read this. Neither can I. Well, what you see here is Prometheus, and these are the rules definitions. So this is an alert rule, and this is the deadman switch rule, and this is an expression that fires always every 15 minutes, regardless. And it's not dependent on some other service or something, but it's just a function. So we can always, it's guaranteed to fire. And what you see here is, well, I'm just going to point it. Is the Iris plan deadman switch. So this is the label which is used to map this alert to an escalation plan and a team. All right. So then the next slide here is, well, this is also, you see that it fires in this alert overview. This is for those familiar with Prometheus, like the graph, in which you can see that it always fires every 15 minutes. But I think here it gets more interesting. I want to have this one actually. Because here is the plan, the deadman switch plan, and this is where it ends. This plan has only one stage. If you would have multiple stages, they would be below it. But what this does is it says, okay, if there is an alert with the Iris label deadman switch, go to Oncall, look for the team deadman switch, the role primary, which is supposed to be the primary standby person for that time, and create an incident with priority low, and the priority is actually mapped to means of communication. So low is configured to be email. If you would put it high, it would be an SMS, and urgent would be a phone call. And then, well, wait 900 minutes. And normally this would be the time in between the first step and the second step, but this time there's only one, so it's really high. It's also the time in which an alert stays active. So I think that's the reason it's so high in this case. And perform this step only once. So you can also make repeating steps. So send an SMS and then after 50 minutes send another SMS. And then if you want to escalate to another team, you can put it below that. So that's the plan. The escalation plan. Well, an escalation plan, if there was an alert, it goes in there, and then it looks up in Oncall who's on call, but it gets it back, then it creates an incident. So this is the list of incidents for the deadman switch, and you can see that it fires, well, roughly every 50 minutes, or actually more, well, just well enough. And you can claim it. Normally a standby person would claim the incident to show that that they're working on it, and if it's claimed, it doesn't escalate further in the plan. So that's something that you would want to do. Then, and then, oh here's my plan again, and then there's also messages, but those are trivial. Well, so like I said, the deadman switch plan is priority low, so it sends an email, and deadman snitch is, oh no, I first I'm going to show Oncall. This is Oncall, and this is the team of the deadman switch. This is the calendar, and you see the poor man, deadman snitch, is always on call, so he has no rest. He has to be alert all of the time.
Even though he doesn't have rest.
Also, he has no phone number and no SMS number, only an email, because that's all we need. And this email address is an email address that triggers the deadman snitch service, but I'll show you that later. What's more interesting? The team info, in which you can see the users of the team and the roster. This is the deadman switch, that's the only person in the roster. So only he gets scheduled, and this is the schedule, so 24/7 schedule, and it's filled in every week. You can also do more fancy stuff like subscribe to other teams and stuff like that, but I won't go into that. And here is the settings page, and here you can see my credentials, or the credentials which you would want to receive SMS and phone calls. Alright, so the messages, and finally the deadman snitch page is this. It's a service, again, managed service, yes, in which it just listens for pokes, for emails in this case, and if it gets an email then it's happy, and if it doesn't get an email, in this case for 30 minutes, but you can also put it on 1 hour or 50 minutes or something like that. If it doesn't get one in 30 minutes, then it will trigger an alert, and that alert is also being sent to the engineer on duty, so that he can take action and see whether something is wrong. And for this, in this case, we also use message birds for that, and we use the email to SMS service of message birds. So that's deadman snitch. Let's see. Yeah, findings. What did we find out while implementing this? Well, first of all, we thought, okay, we have to put effort and resources in the beginning to make it worthwhile and scalable for the long run. But still, I think the amount of manual work that needed to be done to get it work, well, it's more than we thought it would be. So that would make a good case for a managed service after all. Maybe still not for us, but I think for many people, smaller companies, that might be the best solution. But I don't know for us. Then the collaboration with the LinkedIn developers is really good. We even did a penetration test on it ourselves at Bol.com by our security team, and they had like a huge list of things. Well, not big things. They have a list of things that could be improved, and we just send it to them, and they just fix it all the way. So they're very fast in that. And also, when we said, okay, we want to have this kind of feature, then they just create it. So in that way, it's a bit like a service. And then split design, like you have Iris and you have Oncall. That's actually not ideal. It's also a thing that at LinkedIn they just did it like that because they had 2 developers and they could split the work in that way between the both of them without having to do too much with each other or working together or being each other's bottlenecks. So that's the reason that's actually being split. But from a user perspective, it doesn't really make sense to go to Iris for your plan and the message overview and to go to Oncall for the schedule. That's not really logical. So we'd rather not have that, but it's still there. So it might be together in the future, but it has to be done by LinkedIn. Also, if you want to silence alerts, you have to do that in Alert Manager. So functionality, it's a bit scattered all over the place. And it wrote scattered, I think scattered is the word. But yeah, so it's a bit all over the place. You have to create your alert in Prometheus, silence it in Alert Manager, go to the plan in Iris and check your calendar in Oncall. So that's not intuitive, actually, not really. So that could be better. Yeah, and sometimes things we found is that sometimes the database connection can be a bit buggy, but it's more our implementation, I think, than the product. The components don't really recover, so we had to create some things that it would be restarted every once in a while. So I think with the other managed solutions, I think those ones would be better in their hands than this. But we'll get there. So yeah. This defines it, and then that was kind of it. But I also can show you more around in the tools if you like to, or if you have some specific things that you want to know. Are there questions, actually? Yes?
What are specific downsides of being a split tool? Because I actually can see possible value in that. If you say that, well, we as a platform team, we already make a default escalation plan for certain services you can order from us, and then as team you only need to interact with Oncall.
Yes, but you still also need to have your own plan because the plans are also tied to the team. So you as a team you also need to have your plans in Iris, and we do provision plans in the team automatically. So every team has a default plan already that they can use. So, but the alert overview is always in Iris, so you have to be there for that. So yeah, you always have to interact with the both of them. So, but I think in a way it does make sense because the 2 things are kind of different. It's not bad that they have been pulled out of each other, but it would make even more sense, I think, if they were just like tabs in the same GUI. Yeah. Different environments.
Yeah, you started at the beginning that you evaluated different solutions for your problem, and that you choose this one. One of the main reasons was also the cost for it. Are you still now, when you've now worked with it and implemented it, are you still happy with your choice?
Well, I think the thing was from an engineering perspective, it's fun. It's nice to build something, to get it to work, to dive into it. I mean, it is the part of the stack from my team that we have to program and develop software most. So personally, I do like it. I think for the business it might also be worth it because we're planning to grow quite fast in terms of amount of developers, and for all the other ones you have to pay like maybe 10 euros, 20 euros a month per developer, and it just doesn't scale. So I think also finance-wise it's alright. But I think if you're a smaller company, like mid-sized or small size, then you better not do that. I think you just better pay for a managed provider. That would make more sense, I think.
Okay.
Any more questions? Yes.
So what happens if your service goes down? Who notifies you then?
If the service goes down, which service?
Well, one of them. So basically, your alerting service goes down. Who alerts you then?
Well, the thing is that's the deadman switch.
That's what the deadman switch does.
Yeah, if what?
That's what the deadman switch does.
Yeah. So if one of the things goes down, then the email to the deadman switch is not being sent, and then after 30 minutes, it will say, hey, I haven't received an email in 30 minutes. Well, then something must be failing, and then that one sends an SMS to the standby engineer. And the one thing that is still a point of failure would be like the SMS provider. So the message bird, we use it both in the happy flow, and we also use it in the deadman switch. So that's still a weaker point. We better use another text message provider for that. But yeah. So does it answer your question?
Yeah, I think so.
Right.
How long did it took you from discovering this tool to having it in production?
Well, we do have it in production. It's still not really ideal finished yet, so it still does take maintenance. But I think that, well, maybe a little less than 1 year now, something like that. But it's not full-time work. It's something that a period of time you work on most of the time, and sometimes you don't really do a lot of it. But it's still quite some effort. Yeah.
But if you will set up it now from scratch, how long will it take with the experience?
I think the most difficult part is to get the synchronization in order, I think. The other things are, with the knowledge, not too hard, I think, to do. So, well, maybe a few weeks or something. If in a new company with a new something like that, but maybe even more, something like that.
So I noticed that you said you use Kubernetes, which uses desired state management.
Mm-hmm.
And so if the service or pod is unhealthy, Kubernetes will just kill it and start a new one up. How do you handle that alert case? Like, because if it goes down, I might get a message, but then a minute later it might be fixed. So
well, you can, if you don't want to have an alert for that, you choose the up metric in Prometheus normally for that. And you can use the for statement in Prometheus. So you say, okay, if it's alerting for like 10 minutes or something like that, then I want to have the alert. So normally you would do something like that.
like a grace period.
Yeah.
Okay.
Right. Any more questions? Yeah.
Is it also placed on the same network?
As
Do you have it on the same network, or it's isolated? Because if it would be on the same network, it would just, if network goes down, you have all your monitoring.
You mean like,
because it's in one bucket.
yeah, like the Iris and Oncall.
Yeah.
Yeah,
Or
those are
the snitch, swatch and snitch, or is it isolated environments? Or
Iris and Oncall are on the same network, but Prometheus is on another network, so there are namespaces in Kubernetes. So, and I'm not a networking expert, so I don't really know the ins and outs of how they're tied together, but the monitoring things, so the Prometheus and Alert Manager are in another space than Iris and Oncall are.
So I think what he actually meant is your deadman switch.
Mm-hmm.
Say your entire network goes down or your entire uplink goes down. How is the deadman switch then triggered? Is that an external service switch?
Yeah, it's a SaaS, so it's on the internet. And it's, yeah.
That's more sexy.
Yeah. Alright, so this is the question.
I'm guessing your Kubernetes cluster is also on the internet.
Yeah, it is. But it's not another internet.
Yeah.
It's a multi-internet. It's a multiverse. Alright, well, was some question there? Or nothing more? Then I think we'd call it a day and go for drinks.
Yeah.
Yeah.